Okay, we're going to take a look at continuing on with solving rational equations. So the first thing we're going to do is take our worksheet out from last lesson when we started this, 10.4 day 1 worksheet, so have that one out. But we're going to run through a couple of problems. I want to run through number 9 and number 10 here, just to remind you what we're doing. Remember, we want to think about the least common multiple of the denominator. So what do I need to multiply by that could clear out all of the denominators? Remember, we do want to take into account that k in this case cannot be equal to 0, because if either of these k's, if k was 0, we'd have an undefined. Then I'm going to need to multiply by a 2 everywhere. I'm going to need to multiply by a k squared. And one thing I know that trips people up sometimes is they think they need to multiply by the k squared and the k. That's not the case, because if I multiply by k squared, it will clear out that k. So I'm going to multiply by 2k squared on this one. And I know sometimes people don't write it down for each of the individual ones, and you don't have to. I just think it's easier to keep track of. If I multiply every single term by 2k squared, then we're going to be able to see what's going to happen when we start canceling. I come over here, my k squareds will go away, and I'll be left with 2. My 2 will go away, and one of these k's will cancel that k out, and I'll actually be left with k times k plus 3. Again, I'm going to do this in 2 steps. You can do this in 1 step, it's fine. Is equal to these 2's cancel out, and it's k squared. And now when I multiply 2 plus k squared plus 3k equals k squared, actually some good stuff happens here, because if I was to subtract by k squared, those k's go away, and I'm left with 2 plus 3k equals 0. And now I can minus 2, and I get 3k is equal to negative 2, and I divide by 3. K is negative 2/3. I do want to make sure, I want to make sure that my extraneous values were not, didn't come into play here. So negative 2/3 is the answer. Now the one on the bottom is interesting. We always want to factor to begin with, and if I factor this one, it's h minus 3 squared, which is h minus 3 and h minus 3. And now this one over here is h times h minus 3. So I get lots of people who start this one off and they think I need to multiply everything by an h and 2h minus 3's. And that's fine, we can do that. Let me grab a different color just for the sake of the game. So you can go through here and do h. Oh, I got to go off to the side. H cannot be 0. H cannot be 3. And then I'm going to multiply by h minus 3, and I'm actually just going to make it squared. And I can multiply by an h and then h minus 3 squared. Because I got to get rid of these 2. Go away with those 2. This goes away with this, and this goes away with one of those. So I'm left with a 9h on this side. And on this side, I'm left with 3h times h minus 3. And I get 9h equals 3h squared minus 9h. And as I bring maybe this 9h over this direction, I get 0 equals 3h squared minus 18h. And now I can factor out a 3h, and I have h minus 6 equals 0. Set them both equal to 0, and h is 0, and h is 6. Notice we can't forget about our original. We have h equals 0 as extraneous, and h is equal to 6. Okay? Now, some of you might be thinking, I did that a little bit differently, because if we go back to the original problem, and I look at 9 over h minus 3 squared, that's what that really is, that's h minus 3 squared, equals 3h over, and now I have h times h minus 3. So I rewrote the problem, but I had the denominators factored. And some people are like, can't I just cross these h's out? And yes, you can. And I get 9 over h minus 3 squared equals 3 over h minus 3. And this actually becomes easier to work with, because now if I could cross multiply, but it's easier just to multiply everything by h minus 3 squared. So I can go here, h minus 3 squared, h minus 3 squared. These go away. 9 equals, one of these goes away, and now look at what I have. I can distribute this. I'll skip that step this time. 3h minus 9, add the 9 over, 18 equals 3h, h is 6, which is the same thing I got down here. But recognizing that I could simplify one of the fractions before I even start actually makes the problem go faster. All right. I had mentioned when I handed this worksheet out that this one needed the quadratic formula, because remember, you have 1 over first guy's job, hours for job, or days, whatever it is, plus 1 over second guy equals 1 over together. We have that formula. Bill's father can paint a room in 3 hours less than it takes Bill. Together they can paint the room in 3 hours. So if I think about Bill, let's see, Bill's father is faster. So let's go with, here's Bill, and let's go with Bill's dad is 3 less, and together it's 1 over 3. That's pretty standard. I've got, so if Bill can do it in 10, Bill's dad can do it in 7. So sometimes you want to make an equation. So I'm going to multiply everything by a b minus 3, and a 3. A b minus 3, and a 3. I'm going to go 3b and b minus 3, and 3b and b minus 3. And now my b's cancel out, and I'm going to distribute this, if that's okay with you, 3b minus 9. And then I've got my b minus 3's cancel out, so I get 3b equals, my b's cancel out, and I get b squared minus 3b. Again, I just went ahead and distributed those, and I'm ready to go. This is 6b, right? This is 6b, and I'm going to move that 6b. So I've got 6b minus 9 equals b squared minus 3b. I'm going to move these guys this direction. 0 equals b squared minus 9b and plus 9. And this is where we realize I can't factor it, so I'm going to use the quadratic formula. And I'm going to say a is 1, and b is negative 9, and c is 9. And I will do the discriminant, which is big D, which is the b squared, and I minus 4ac, and I get 81 minus 49, which is 32. Okay, so now x is equal to negative b, but I'm really solving for b. Negative 9, right? The opposite of negative 9, plus or minus the square root of 32 all over 2. Okay, so if this was the case, I would actually do the math now. So I'm going to take 9, because that's going to be a positive 9, plus the square root of 32, and I'm going to get 14.65. And I'm going to take my 14.65, and I'm going to divide by 2, and I get 7.3, and that would be hours. That's for Bill. But then I need to do the 9 minus the square root of 32, which gives me 3.34, and Bill would be 3.34 divided by 2, which is 1.67. Well, you have to go with the reasonableness of the problem now. If Bill did it work in 7.3 hours and his father was 3 hours less, then his father would have been 4.3 hours and Bill is 7.3 hours. How long did it take Bill to do the room? If Bill did it in 1.67 hours, 3 hours less is a negative time. So unless Bill's father has a time-traveling device, that would be a unreasonable answer. It would get thrown out. The answer is 7.3. Okay, we're gonna do a circuit worksheet today, and I'm actually gonna take you to so take out the circuit for 10.4 day 2 circuit. So if we did not pass out 10.4 day 2 circuit, hit the pause button, make sure everybody has one of these. I'm going to turn you to the second page on the top right, because this is a problem that has one extra step in it that makes it a little bit tricky, and we'll do this one together, and then you can go back to the front page and do the circuit like we've done circuits all the way through. On page 2, on the back, upper right, this is good to do this too. This is going to be number 8, okay? So as you're going through remember you solved the problem, you look for the answer, that's your next problem. So you start with number 1, your next problem is number 2, and so on. So this is number 8. Now the problem with this one is once you get the hang of these problems, we know that we need to go here and say x plus 2, x minus 2. So it's fairly obvious that x cannot be equal to negative 2 and x cannot be equal to positive 2. I'm going to go plus or minus. But the issue here is I have an x plus 2 and an x minus 2 and I have an x plus 2. This is not x minus 2. 2 minus x is not x minus 2. 2 minus x is equal to negative x plus 2. And what I need to do to change that into an x minus 2 is I need to factor out a negative sign. Oh no, not that, anything but that. So what that does to the problem is it makes this denominator x minus 2, which is fine, but it also makes the whole portion of the problem negative, and it's a minus x there, okay? So let's get rid of the plus sign. So I'm allowed to take this negative sign, and I'm going to insert it and make it a minus problem instead. And now I can go through, and I can multiply by x plus 2 and x minus 2. And I can multiply by x plus 2 and x minus 2. But I got to pay attention to that minus sign. X plus 2 and x minus 2. And now my canceling here is beautiful. This is all gone. The minus 2's gone. The x minus 2's gone there. And we changed that, so that one's dead. And then this one's gone too. And what do I have? On the left over here, I have x squared plus 4. Watch out, minus x times x plus 2 equals 2 times x minus 2. Now I'm going to take and I'm going to distribute these guys in, and I'm going to get x squared plus 4 minus x squared minus 2x equals 2x minus 4. And when I start combining like terms, I'm going to go ahead and x squared minus x squared is canceled out. And now I'm going to add 2x over because I like positive numbers and they like me. And I'm going to add this 4 back. And I'm going to get 8 equals 4x. And I'm going to get x equals 2. But wait, I actually have x cannot be plus or minus 2. So we did all that wonderful work, and the answer is no solution. And then we'll go find our no solution in our answer, and that will be number 9. So now you're going to have to go back and start with number 1 and start solving that one. Pro tip number 1, you're going to need to multiply everything by 4x to clear those denominators. Have a great day.